Hello guys, in this video I want to show you how I created a battery pack for this old IBM Thinkpad. What's the model? 380E. So I bought this laptop long ago. It was my first laptop. I bought it used without battery. It was already old when I bought it, but it came without battery, with just power adapter, and I used it with power adapter, but I never had a battery for it. And recently I found it, and I decided to finally create a battery for it, because now I have a 3D printer and some knowledge about batteries. So I found on the internet the manual for this laptop, and the manual had this pinout diagram for the battery. And from this diagram we can see that it doesn't have like modern laptops have the data communication. So it's not a smart battery, it's just a dumb battery. It doesn't communicate with the laptop. So it just provides voltage on some pins and thermal connection. So the laptop monitors temperature of the battery. And to create the battery pack, obviously we want to use lithium-ion batteries because they have higher capacity and they are readily available right now. So let me just put the laptop aside and show you what this battery pack have inside, and show you. So here we have lithium-ion cells, the regular cells that you can find anywhere, and the configuration is 3 in series and 2 in parallel. So this is the first bank, second and third. So the total voltage is around 12 volts. But we cannot use lithium-ion batteries without management board. So here is BMS that can be bought on Aliexpress. This board is for 3S configuration. Doesn't matter how many individual you have in parallel, but in this case we have 2 in parallel and 3 in series. This BMS controls overcharge, over discharge, and I believe it also has some balancing, those resistors, small resistors there. This BMS board to protect the cells, and we also need a thermistor. This thermistor is connected to those terminals. as we can see on this diagram. The resistance should be between 4 and 30 kilo ohms. So I used some thermistors that I had laying around from some old battery pack, I believe. So I used it here. I can show you, I can check what resistance. The thermistor is connected. Here it's 3 and 6. Yeah, 3 and 6, and we have like 10 kilo ohms at 20 degrees Celsius. So it's in the range of this 3 to 30 kilo ohms. Yeah, so another interesting thing is, so I 3D printed this case, but I needed some terminals to connect to the spade terminals inside the laptop. So I need something to connect to those terminals. And the only thing that I could think of how to connect to those, so to use those common pin header thing, they usually come with some modules from Aliexpress, so I have plenty of them. And if I just pull out one of those things, you see it's like a small fork, and it just about the right size to grab this terminal. Yeah, so I decided to use those things. Yeah, I have some grooves there, and a hole from this side, and 2 of them actually per terminal, because I need to like increase connection points. So with 2 per terminal, I have like 4 connection points. Make better connection, just not so the terminals are not heating up. So you just put it there through the hole, and from the other side just bend it, connect them together, and solder wire. So that's how I solved this connection thing. Yeah, and it works pretty good. No issues so far. Yeah, this is the first version. I have some issues with the case. This thing is pretty thin and it broke, and I glued it, but in the version that I uploaded to the printables, I have it beefier a bit, and also it goes a bit around, so it's not that weak as it here right now. But I didn't print a new version because this one works and I don't want to waste more plastic. So it just closes, snapping. Yeah, and that is. It can be glued, but I didn't glue mine because yeah, I might need to disassemble it for some reason. I don't know. Yeah, and it goes like that. This thing should be like pulled, and it goes down, and this thing moves over and closes like latches, so it's not going anywhere right now. Yeah, and with this battery pack, laptop works, and having modern lithium-ion batteries gives it plenty of runtime. Yeah, so you can see it is starting up. Yeah, battery LED glowing, beeping. It has Windows 98. You can see it's booting from this battery. So it's working fine without issues, charging with the original power brick. Let me show you. Windows Microsoft China has booted. Can close it. And I can touch the charger. So the LED changed color to amber or yellow. So here I probably cannot show you, but it has like a charging sign. It's telling me that like it has 80%, and if I remove the power cord, so it's showing that working from the battery, and it's telling me like 100% left, but the percentage might be inaccurate because the battery does not provide information about its state, about its percentage, because there is no communication. So laptop itself somehow tracks how much energy goes into the battery and goes out of the battery. I'm not sure how accurate this measurement, but yeah, that's how it works. This I don't remember where I found this information, but somewhere I found that this exact model, works with nickel magnesium batteries and with lithium ion batteries. So this is like the first version they released that started using lithium ion batteries. So I think that's why I was able to use lithium ion batteries, lithium ion cells in my custom battery pack. So I think that's it. So if anyone wants to like revives their old laptop, vintage retro laptop, you can create this battery, just 3D print it and assemble. The parts are pretty accessible. Just put some time and you will have some retro vintage laptop that is actually portable again. That's all. Thank you. Bye.